Hello everyone. In this session, I will cover the topic concept hierarchy. This concept hierarchy we need to understand to talk on the OLAP operations. If your concept hierarchy is clear, then you can easily understand the OLAP operations. So today in detail with example, we will see concept hierarchy. As you know, your data warehouse database is based on the multidimensional data modeling, right? And the records are organized into the form of various dimensions, and each dimension includes the multiple level of abstraction, and that describes the concept hierarchy. As we know here, the data warehouse data is used by the top management people, right, to do the analysis of their business, right? So not only this data is used by the your top management people for analyzing a particular concept with the one point of view, but also different point of views. For example, if you take the example of your sales data, so top management will analyze this data not only for the country, but my manager people need to analyze the data city wise, right, state wise, right, and also country wise. Right. Similarly, not only your top management people will analyze this data for a particular year, but also your management people need to analyze this data day wise, weekly, monthly, right? Also may be required quarterly, right? And also yearly data, right? So here concept hierarchy, right? OLAP supports the user-friendly environment for the interactive data analysis, and how with the help of concept hierarchy. OLAP supports this user-friendly environment for the interactive data analysis with the help of concept hierarchy. So we will see here one example of concept hierarchy. So what is concept hierarchy and what is the role of concept hierarchy here? Concept hierarchy defines a sequence of mapping from a set of low-level concept to higher-level, more general concepts. Right? Here is the important point to be noted. Here, concept hierarchy maps the set of low-level concepts into higher-level, more general concepts. As we discussed, city-wise data we can map to state-wise data, state-wise data we can map to the country-wise data, and so on. Right? So if we take the example of location dimension here, right? So city values for the location include, for example, Vancouver and Toronto, right? So each city, however, we can map to the state to which it belongs, right? And here, state can in turn be mapped to the country, right? So Canada or United States, right? With example, we will see here what are the different cities are there that we can map to the state, and state we can map to the country. So these mappings from a concept hierarchy for the dimension location, right? Maps a set of low level concept, that is city, to the higher level, more general concept, that is countries here. So low level concepts are city and higher level concepts are countries, right? So your data warehouse cube may contain the city-wise data that can be mapped to the state-wise data, right? So how it is possible? With the help of aggregate queries, right? Group by queries, aggregate queries. So city-wise data you can map to state, state-wise data you can map to countries, and so on, right? So here in the next slide, figure shows one example, right? So these are the cities in the Canada, right, country, and these are the cities: New York, Buffalo, Chicago, right, in the USA, right? So this city wise data you can, with the help of concept hierarchy, you can map to the state wise data. Then state wise data you can map to the country wise data, right? Means what your, if your data cube contains the city wise data, summarized data, right? Always my data will be summarized data here. So this summarized data, with the help of concept hierarchy you can retrieve more summarized data, right? So city wise, by using aggregate functions, right, you can retrieve here state wise data. So here grouping will be city wise, state wise, country wise, right? So as per the application requirement, right, your manager people can retrieve this data with the help of concept hierarchy, right? So here this slide shows the order of the concept hierarchy, right? And one concept can have multiple concept hierarchy, right? So that we will see here with one example. Street can be mapped to city, right? City can be mapped to state, and state can be mapped to the country here, right? So here my time dimension, this is the concept order of the concept hierarchy for the location dimension, right? And this is example for the time dimension, right? So this time dimension is shown here with the two concept hierarchy. One concept hierarchy from day to week, right? Day wise data you can map to weekly data. Weekly data you can map to the yearly data. Similarly here, another concept hierarchy, if your manager want to do the analysis monthly. So here day wise data can be mapped to monthly data. Monthly data you can map to quarterly data, and quarterly data can be mapped to the yearly data, right? So this is another example of the concept hierarchy, right? So here many concept hierarchies are implicit within the database schema, and as per application requirement, manager people can use to analyze their business, right? So if it is a sales business, right? So sales we can analyze state-wise, country-wise. Sales we can analyze monthly, quarterly, or yearly, for example, right? Here is the another example. Here there can be more attributes, right? Multiple attributes for the order of the concept hierarchy. First is the your flat number, right? Flat number you can map to street, right? Street can be mapped to city. City can be mapped to state, and state you can map to zip code. Zip code can be mapped to country, right? So as per application requirement, you can analyze the growth of your business, sales of your business, so street wise, right? Then city wise, state wise, and so on, right? So this is shows here the order of the concept hierarchy for the location dimension. Thank you. I hope you are clear with this. Now we will use this concept hierarchy concept in the OLAP operation. So next video, next session, we will cover the OLAP operations in detail, where we apply this concept to analyze the more summarized data.